Welcome to the video series and CAN protocol. This is the seventh video in the series. In this video, we are going to see CAN error frames. An error frame is generated by the node whenever it detects an error in the CAN network. The basically error frame consists of two different fields. One is error flag field. It is basically superposition of error flags contributed from different station whenever they detect an error, followed by an 8-bit error delimiter field. A CAN node can be either in error active state or in error passive state. We shall see when does a node enters into the error active state as well as in the error passive state. First we shall see what is error active state. By default, all the CAN controller are in, or CAN nodes are in error active state. That is the normal state where all the nodes can send all types of frames including the error frames. Error passive state, in this case there is a potential problem with either the controller node or its connectivity. Therefore it is not allowed to send an error frame but can send all the other types of frames. There are two types of error frames. One is error active frame, another is error passive frame. So this is the state diagram for a CAN node. So initially and each node will have two internal counters. One is called as TEC, abbreviated as transmit error count. Another is called REC, receiver error counter. So initially the node will be in the error active state. In this case the TEC and REC will be always less than 127. Say whenever transmit error count and receive error count increases beyond 127, either of them, it will enter into the error passive state. And it will remain in the error passive state until both transmit error count and receive error counts are less than 127. If on entering the error passive state, if the transmit error counts goes beyond 255, then it will goes to the bus off state and CAN controller will be reset and it will be the node will entering into the error active state. So first we shall see active error frame. So active error frame, error active node, whenever it detects an error, it will generate active error frame where the node interrupts the normal or current transmission of the message by generating an active error flag. An error flag consists of 6 consecutive dominant bits. So whenever it generates 6 consecutive dominant bits, the error flag activity basically violates the bit stuffing rules. In CAN, no nodes can either transmit 6 consecutive dominant or recessive bits. If so, the sender and receiver on detecting them rejects the erroneous frames completely and do not process it any further. All the other stations which recognizes the resulting bit stuffing error will in turn generates a frame themselves called as error echo frame, which results in contribution of superposition of error flag, and it is 6-bit in length. So after sending the error flag feed as well as superposition of error flag, the error delimiter bus activity returns to the normal after sending 6 recessive bits, and then the interrupt node attempts to resend the aborted message. That is current abortion which has been done here will be reset. Next is passive error frame. Whenever a passive error node detects this type of error, the node transmits an error passive flag followed by an error delimiter flag. Here error passive flag is basically 6 recessive bit. Hence the error frame in the passive error frame will have 14 consecutive recessive bits. The error delimiter consists of 8 recessive bits and allow the bus node to restart the bus communication cleanly after the error has occurred. I hope this was useful. Thank you.